This is Rambot, and today we're diving into C++ project configuration with Raylib, CMake, and VSCode. Alright, let's create a C++ project using CMake and fetch Raylib as a library. We'll use Raylib as a library to run this project. To get started, make sure you have Visual Studio Code installed. You should also download CMake and Ninja. I'll provide the link, download the zip file, extract it, and add it to your system's environmental path variable. For your compiler, you can choose between Clang, MinGW, or Visual Studio. I recommend installing all of them and experimenting with each one. As a beginner, if you're new to C++, you'll also need VC package to easily fetch libraries. You can visit the VC package Getting Started page to learn how to install and use it with CMake. The documentation there is very helpful for setting it up. Now, how can you confirm that all the required software is installed? You can check like this: type CMake -- version in your terminal to see which version you've installed. Similarly, type Clang to verify if it responds. This indicates it's installed correctly. For Ninja, you can also check to confirm everything is in place. For VC package, after installation and configuring the environmental path, simply type vcpkg in the terminal. If it responds, it's set up correctly. If you face any issues, let me know in the comments and I'll create separate videos to address them. Once everything is installed, navigate to the folder where you want to create your project. Let's create a new folder. For example, my Raylib project. Make sure to avoid using spaces in the folder name. Then right-click, choose Show More Options, and open it with Visual Studio Code to start. Great, we're here. Awesome. Once you're in Visual Studio Code, you'll need the C++ IntelliSense and extension pack. Additionally, you'll need to install the CMake extension. Download the VSCode CMake extension from Microsoft's Marketplace. Once that's installed, you're ready to get started. Use Ctrl+Shift+P and type CMake Quick Start. Enter your project name, such as my Raylib CPP project, select executable, and add a new preset. Choose the toolchain file for your compiler. Let's name this preset My Raylib to keep it consistent. Now, we need a CMake toolchain file. Locate the directory where you installed your VC package. Navigate to the scripts folder. Inside, there's a build systems directory. We need the VC package CMake toolchain file from here. Copy this path, paste it, and ensure the slashes and backslashes are formatted correctly. With that, our toolchain setup is ready. The next step is to create a vcpk.json file. Inside this file, we'll define the list of dependencies we need. Open the file, set the project name to Raylib, and add Raylib as a dependency. By the way, Codium is an amazing AI writing assistant. It's free, user-friendly, and highly efficient for tasks like these. Okay, I've added Raylib as a dependency. We're almost done. Well, not quite done, but we're getting close. Next, go back to your CMake lists.txt file and update the CMake version to 3.21. That's the version I'm using right now. After that, open your terminal and type vcpk install. This command will install the dependencies defined in the vcpkg.json manifest. Wait a moment for the process to complete. Once it's done, you'll see a find package output. Copy the find package and target /lang libraries entries, then go back to your terminal. Open your CMake lists.txt file and paste them there. Personally, I prefer placing the target linked libraries line at the end of the file. Make sure to replace the placeholder name with your actual project name, my Raylib project. Remove the default main entry, update the target link libraries, and save the file. When you save it, you might encounter an error. Don't worry, here's how to solve it. If the error is related to VC package, navigate to the project directory. This issue isn't too difficult to fix. Simply append the prefix path using the correct syntax. Use the source directory path. For this step, Specify the VC package installation directory, such as x64 Windows, depending on your operating system. Ensure you're pointing to the correct folder inside the VC package directory, not the share folder. Also, avoid adding a trailing, untrailing slash to the path. Once you save these changes, the error should disappear. Next, let's write a simple implementation using Raylib. Include Raylib, and when you save the file, Visual Studio Code might show an error. Don't worry, we'll address this in the next step. So click on it and add the include paths. With VC package properly configured, this will resolve issues inside your projects, so you won't encounter any further problems here. Alright, I accidentally clicked something. No thank you. Let's get back to it. Next, let's create a window with a resolution of 800 by 600, my standard Raylib window, and set the target FPS. After that, we'll create a simple example with Raylib. Let's draw some text like hello and also display the FPS. With these additions, we're nearly done. At this point, we have a simple project ready to use with Raylib. Go back to CMake extension, and in the build section, click to set the preset. Select the preset we created earlier, click on configure, and then build. To ensure everything works properly, delete the cache and reconfigure. It looks like we're almost done. After that, use Ctrl plus Shift plus P and reload the window to make sure everything is set up correctly. Skipping this step can sometimes lead to issues. Reloading resolves those, and it looks like everything is working perfectly now. Reloading is an essential step when working with C++ in Visual Studio Code. What else is left? Let's configure the entire project to make sure everything is finalized. Use the build all command. Now we shouldn't face any problems. Let's run the project. As you can see, the project runs without any issues, and I can continue coding in Visual Studio Code. I hope this tutorial helps you learn how to configure Raylib in VS Code. I face so many challenges with Visual Studio Code, C++, and Raylib, but this setup solves them all. With this configuration, you can also set up libraries like FMT, SDL, IMGUI, and more. This setup provides a strong foundation for many C++ projects. If this tutorial was helpful, please like the video and subscribe for more tips and guides. Let me know in the comments if you have questions or ideas for future content. Thank you for watching, and see you in the next video.